the birth of the Magnetar. Somewhere, far beyond the Milky Way's tranquil arms, lies a place where the laws of physics are pushed to their breaking point. A realm so extreme that even atoms, the very building blocks of matter, are torn apart by invisible forces. This is the story of the strongest magnetic field in the universe, a force a quadrillion times stronger than Earth's, capable of reshaping reality at a subatomic level. It belongs to an object so dense, so powerful, and so dangerous that if you were to approach it even from 1,000 kilometers away, it could tear the iron straight out of your blood. This monster is called a magnetar. When a massive star, many times the size of our sun, runs out of nuclear fuel, it dies in a supernova explosion. The core collapses inward under its own gravity, crushing protons and electrons into neutrons, forming a neutron star, one of the densest objects known to science. But occasionally, something even rarer happens. The collapse doesn't just stop at forming a neutron star. It spins so fast and compresses so violently that it twists the very magnetic field lines of the universe around it. The result? A magnetar, the most magnetic object ever discovered. Magnetars are cosmic oddities. Only about 30 are known to exist in our entire galaxy, and each one is an enigma wrapped in magnetic fury. Their fields are up to 10-15 Gauss. For comparison, Earth's magnetic field is just 0.5 Gauss. That's not a small difference. That's a difference of 20 quadrillion times. To put it in perspective, if a magnetar were as close to Earth as the moon, every magnetic stripe on every credit card, every computer hard drive, and even the atomic structure of our DNA would be torn apart instantly. But how does something like this even form? It begins with the collapse of a supermassive star, one at least 10 to 25 times heavier than the Sun. When the star runs out of hydrogen fuel, its fusion engine stalls. Gravity takes over, crushing the core. Temperatures skyrocket to over 100 billion degrees, while the outer layers explode outward in one of the most powerful events in the universe, a supernova. What remains behind is a sphere of ultra-dense neutrons, no wider than a small city, about 20 kilometers across, yet containing more mass than the Sun. That's the neutron star, the seed of what could become a magnetar. But only if two special conditions are met. The star must have an extremely strong initial magnetic field, and it must be spinning incredibly fast, hundreds of times per second. When these align, the newborn neutron star acts like a dynamo, amplifying its own magnetic field to unimaginable strength. It's the same principle that gives Earth its magnetic field, but magnified to cosmic proportions. The result is a newborn magnetar, a celestial powerhouse radiating invisible magnetic fury through the cosmos. Within just a few seconds of its birth, the magnetar's magnetic field begins to slow its rotation. All that energy has to go somewhere, and it does, in the form of intense radiation bursts. Sometimes these outbursts are so powerful they can be detected across the galaxy, even 100,000 light-years away. One such event was recorded in December 2004, when a magnetar named SGR 180620 suddenly released more energy in a fraction of a second than our Sun emits in 150,000 years. Scientists believe these bursts occur when the magnetar's crust, yes, even this dense object has a kind of crust, cracks under the strain of its own magnetic field. Imagine the stress, magnetic forces twisting the surface like a steel beam under cosmic pressure. When it snaps, the result is a starquake, releasing unimaginable gamma-ray energy across space. It's one of the few natural events in the universe that can actually warp spacetime itself. If this kind of mind-blowing cosmic power fascinates you, take a moment now to subscribe to the channel. We dive deep into impossible truths of our universe, things that defy human understanding, yet exist all around us. Hit the bell icon so you don't miss the next chapter of this magnetar's story. Even though these monsters are deadly, they don't last forever. A magnetar's ultra-strong magnetic field decays over time, usually over about 10,000 years. When it does, the violent outbursts fade, and the object becomes a quieter, slowly rotating neutron star once again. But in that short cosmic lifetime, a magnetar can change the environment around it forever, energizing nearby gas clouds, disturbing space dust, and even affecting the birth of new stars. They may be rare, but their influence ripples far beyond their size. Each one is a living reminder that the universe is not gentle, it's powerful, chaotic, and breathtakingly violent. The magnetic power beyond imagination. When you stand on Earth and hold a simple magnet in your hand, you're feeling one of nature's quiet wonders. A force invisible to the eye, yet strong enough to pull metal, guide compasses, and even protect our planet from cosmic radiation. Now, imagine that same force magnified a quadrillion times. That's what a magnetar wields. Its magnetic field isn't just strong, it's absolute. It distorts reality itself. If you could somehow stand near a magnetar, say, within a few hundred kilometers, you wouldn't see much at first. There's no bright, glowing surface or swirling cloud, but what you would feel instantly is annihilation. Even light, the fastest, most unstoppable thing in the universe, bends under its power. Near a magnetar, photons are twisted by magnetic fields so strong they can alter the quantum structure of empty space itself. This is called vacuum birefringence, a phenomenon Einstein could only theorize, but magnetars make it real. In this strange realm, light splits into different polarizations, traveling at slightly different speeds, as if even light becomes confused about how to move. For astronomers, this is not just theory. In 2016, scientists using the Very Large Telescope, VLT, in Chile detected signs of this effect around a magnetar known as RxJ 1856-253-3754, about 400 light-years away. It was one of the first pieces of observational evidence that space itself, the vacuum, behaves differently near these objects. Every known magnetar rotates rapidly, typically once every few seconds. That might sound slow, but remember, this is a star containing more mass than our Sun, condensed into a sphere only 20 kilometers wide. Each rotation releases enormous energy, including bursts of X-rays and gamma rays, and sometimes those bursts turn violent. In 1979, the world's first magnetar flare ever detected hit Earth without warning. Gamma ray detectors aboard satellites suddenly spiked off the charts. The source? A magnetar known as SGR 052666, located in the Large Magellanic Cloud 163,000 light-years away. Even from that distance, it temporarily overloaded sensors, and if it had been closer, it could have scorched Earth's atmosphere. When they flare, the shock waves can trigger radio bursts across interstellar space, brief, mysterious flashes known as fast radio bursts, FRBs. For years, scientists had no idea where FRBs came from. Some even suggested alien technology. Then in April 2020, during the height of a global lockdown on Earth, space telescopes detected an FRB that coincided perfectly with a magnetar flare from SGR 1935+2154. It was the first solid proof that at least some FRBs, those cryptic signals from the deep, come from magnetars. That discovery changed everything. We now know these ultramagnetic stars are not just exotic dead remnants. They are cosmic communicators, sending powerful radio pulses across the galaxy. CTA-1, calm, reflective tone. If discoveries like this make you see the universe differently, don't forget to like this video. It helps others find these impossible truths too. And if you're new here, subscribe now, because in the next moments we'll explore just how magnetars might be the key to some of the universe's biggest mysteries. The question then becomes, how can something so small, so rare, and so short-lived affect the entire fabric of space? The answer lies in magnetic reconnection, the same process that drives solar flares on our sun, but on an unimaginable scale. When the magnetar's field twists and breaks, it releases more energy than 100 trillion nuclear bombs in milliseconds. This sudden release can light up entire regions of space, even altering nearby star systems. It's like watching the universe itself have an electrical storm. And here's the impossible truth. Some scientists believe these bursts could even generate ripples in space-time, gravitational waves, the same kind detected by LIGO in 2015. Although magnetars are not the main source of those waves, their intense quakes could mimic the same effect on a smaller, more chaotic scale. Let's put this into perspective. If you were to harness the magnetic energy of a single magnetar, you could power every civilization on Earth for billions of years. Yet this immense power comes with a dark consequence. If a magnetar ever formed near our solar system, say within a few light years, its radiation could devastate our planet's atmosphere, stripping away protection from cosmic rays. Fortunately, the nearest known magnetar, 1E 1048.15937, is over 9,000 light-years away. We're safe, for now. But in cosmic terms, magnetars are reminders of how fragile our existence is. One slight change in the universe, and everything we know could be erased in a flash of magnetic fury. When magnetars collide, the birth of cosmic chaos, the universe is not still, it is restless. A sea of motion where gravity and magnetism dance in eternal conflict. And sometimes, that dance becomes a collision. When two magnetars, or even two neutron stars, drift close enough, their immense gravity pulls them into a deadly spiral. Each rotation draws them closer, faster, until they finally meet in one of the most powerful explosions known to science. This is called a kilonova, an event so energetic it can briefly outshine an entire galaxy. But when a magnetar is involved, the outcome becomes even stranger and more violent. Imagine two stars, each just 20 kilometers wide, spinning hundreds of times per second, surrounded by magnetic fields trillions of times stronger than Earth's. As they close in, their magnetic lines tangle, twist, and snap, releasing waves of gamma radiation and magnetic storms powerful enough to shred matter itself. The moment of collision sends shock waves rippling through the very fabric of space-time, gravitational waves, like the ones detected by the LIGO and Virgo observatories in 2017. That detection wasn't just a signal, it was a cosmic fingerprint, evidence that two neutron stars had collided. For a brief instant, astronomers around the world saw both light and gravitational waves from the same event. And hidden within that data, some believe, was the magnetic signature of a newly formed magnetar. If true, that means magnetars might not only be born from supernovae, but also from collisions between dead stars. The result? A hypermagnetized remnant spinning faster than any other object in existence. A cosmic engine that could drive some of the brightest gamma-ray bursts, GRBs, ever. But there's a deeper mystery. What happens after such a collision? Some scientists believe the newborn magnetar collapses under its own mass, forming a black hole. Others think it stabilizes, spinning rapidly enough to resist gravity at least for a while. If it survives, its magnetic field becomes even stronger, feeding off the surrounding debris like a cosmic hurricane. For a short time, this post-collision magnetar can shape everything around it, bending radiation, accelerating particles to near-light speed, and powering massive cosmic jets that shoot across interstellar space. These jets, when aimed toward Earth, appear as those mysterious, ultra-bright flashes we detect as gamma-ray bursts. So in a way, every time we observe a GRB in the sky, we may be witnessing the birth cry of a magnetar. CTA-1, mid-scene hook tone. If that realization gives you chills, that every flash of cosmic light could be a magnetar being born, take a second to hit the like button and subscribe to Impossible Truth. Because in this universe, even the dead stars have stories, and we're only just beginning to hear them. The aftermath of a magnetar collision is not quiet. The surrounding space becomes a graveyard of high-energy particles, bathed in radiation and twisted magnetic fields. Matter is ripped apart, reshaped, and fused into new elements. It's in these cataclysmic moments that gold, platinum, and uranium, some of the heaviest elements in the universe, are forged. That's right. The jewelry you wear, the electronics you hold, even the atoms in your bloodstream, may trace their origins back to the death throes of magnetars. So when you see a golden ring, you're looking at the ashes of cosmic violence, the remnants of stars that destroyed each other billions of years ago. It's a reminder that even in chaos, the universe creates beauty. For astronomers, these collisions are windows into creation. They allow us to study gravity, magnetism, and nuclear physics at extremes that no laboratory on Earth could ever replicate. And in that chaos, they've noticed something extraordinary. When a magnetar's field interacts with the surrounding debris, it can temporarily reverse magnetic polarity, creating electromagnetic storms that last for years. This process releases constant radiation, flickering, pulsing, almost like a heartbeat. Some even call it a heartbeat magnetar. These pulses help scientists understand how magnetic fields evolve in the universe, how galaxies, planets, and even stars maintain their magnetic identities. But there's another deeper question, one that scientists still struggle to answer. How strong can a magnetic field truly get? So far, magnetars top the charts at around 10-15 Gauss. But theoretical physics suggests that if conditions were extreme enough, a neutron star's magnetic field could exceed even that, possibly reaching 10-18 Gauss. At that point, the field would be so strong that quantum physics itself would start to break down. Atoms would flatten, space would ripple, and light might no longer behave as we know it. The hidden influence. How magnetars shape the cosmos. Every time a magnetar flares, cracks, or collides, it sends waves of energy sweeping through the interstellar medium. These waves compress nearby gas and dust, triggering shock waves that can cause new stars to form. It's poetic, really. From the death of one star, others are born. The violence of the magnetar becomes the seed of creation. Astronomers call this process feedback, the way dying stars enrich and reshape their surroundings. Without it, galaxies would stagnate. No new stars, no new planets, no new life. So in a very real sense, magnetars, these rare, monstrous stars, are part of the reason you exist. When a magnetar unleashes its fury, it also spews heavy elements into space. Iron, gold, silver, uranium, platinum. These atoms drift for millions of years, eventually settling into young star systems like our own. Billions of years later, they form planets, oceans, and even living cells. It's one of the most profound truths in astrophysics. The universe recycles death into creation. Scientists have even begun to map the influence of magnetars on galactic magnetic fields. In some galaxies, there are regions where the local magnetism is far stronger than expected, remnants perhaps of ancient magnetar storms. By studying these cosmic scars, astronomers can trace back the life cycles of stars and understand how galaxies evolve over billions of years. One such discovery came from the Chandra X-ray Observatory, which found glowing nebulae surrounding magnetars, like halos of energy left behind long after the star's violent birth. These nebulae are full of synchrotron radiation, light emitted by particles spiraling around magnetic field lines at nearly the speed of light. They're silent witnesses to unimaginable power, energy that continues to ripple across space long after the explosion fades. If this connection between destruction and creation amazes you, take a moment now to like this video and subscribe to Impossible Truth. Because what you're watching isn't just science. It's the story of how the universe builds beauty out of chaos. And in the next part, we'll uncover something even deeper. The magnetic field of a magnetar doesn't just affect the environment outside. It also influences the behavior of space-time itself. In extreme cases, it can stretch and twist the very geometry of space, creating what some physicists describe as magnetogravitational coupling. This is still a frontier of theoretical physics, but early models suggest that strong magnetic fields could alter the way matter falls into black holes, or even how gravitational waves travel through the cosmos. In other words, magnetars may subtly reshape the universe, not just through light and radiation, but through gravity itself. Let's travel back in time, billions of years, to the early universe, just after the first stars were born. Conditions were harsh. Chaotic gas clouds, turbulent gravity, and magnetic fields forming from the cosmic soup. Some astrophysicists believe the first magnetars appeared in those primordial ages, influencing how galaxies took shape. Their energy output may have prevented smaller galaxies from collapsing too quickly, allowing for stable star formation over time. Without those first magnetic giants, the universe we see today, with structured galaxies and peaceful star systems, might never have formed. It's humbling to think that invisible magnetic fields created by the deaths of stars may have helped organize the entire cosmos. Today, astronomers are searching for ancient magnetar fossils, the remnants of these magnetic titans from the dawn of time. While their fields have long faded, the scars they left in surrounding gas and radiation patterns may still be visible. The Square Kilometre Array, SKA, a massive new radio telescope being built in Australia and South Africa, will be one of the most powerful tools ever made for this search. It could help scientists map the hidden magnetic skeleton of the universe, revealing how magnetars stitch together the cosmic web. But the story of magnetars isn't just one of science, it's also one of perspective. In a vast, cold universe that often seems indifferent to life, magnetars remind us that even the most violent events can lead to creation. That energy, that chaos, that power, all of it flows into a grand cosmic balance. If stars can die and still give life, maybe that's the story of the universe itself, and ours within it. If that thought moves you, if it makes you see existence in a new light, then you belong here, among the curious, the seekers of the impossible. So subscribe now and don't miss the ultimate limit when magnetism breaks reality. Because what comes next is not just science, it's the edge of reality itself. For all we've seen, the violence, the beauty, the mystery, there's one truth that still defies comprehension. There's a limit to everything in the universe, a threshold beyond which the laws of physics begin to falter. And magnetars, they live right on that edge. Their magnetic fields are so extreme that in theory, they could tear the very vacuum of space apart. At 1015 Gauss, their power crosses what physicists call the Schwinger limit, the point where magnetism becomes strong enough to pull matter out of nothingness. Yes, out of nothing. Space itself starts to boil. Particles and antiparticles flicker into existence, annihilating each other in flashes of pure light. Reality becomes unstable. This isn't fantasy. It's quantum electrodynamics, the deepest layer of physics we know. And inside a magnetar's field, that layer begins to fracture. Scientists call this phenomenon vacuum birefringence, a quantum distortion where even light bends differently depending on its polarization. In 2016, the European Southern Observatory captured the first hints of it around a magnetar named RxJ 1856.53754. For the first time, we saw light itself struggle to move through space normally. It was like watching the fabric of reality ripple under invisible pressure. But if magnetars already push physics this far, what happens if something even stronger exists? A hypermagnetar, perhaps, a star born from the collision of two neutron stars, spinning 1,000 times per second, with a magnetic field 100 times stronger. Some models suggest such an object could exist for only a few seconds before collapsing into a black hole. In that instant, it might unleash a gamma-ray burst capable of sterilizing entire galaxies, a cosmic flash brighter than 1 billion suns, ending as quickly as it began. If this makes your mind spin and your imagination soar, take a moment to like this video and subscribe to Impossible Truth. Because what you're hearing now isn't just science. It's the frontier where imagination meets the universe itself. And then comes the paradox. When a magnetar collapses into a black hole, what happens to its magnetic field? Does it vanish? Does it get swallowed? Or does it imprint itself onto space-time forever, leaving a scar that gravity alone can't erase? Physicists debate this fiercely. Some believe the field lines reconnect and fade. Others propose that traces of the magnetic structure remain, frozen in the curvature of the black hole's event horizon. If true, that would mean magnetars can rewrite the memory of the universe itself. Imagine standing on a planet a few light years away as a magnetar collapses. The flash of energy arrives like the wrath of creation, a blinding pulse of gamma light that scorches the upper atmosphere, alters the chemistry of the air, and turns night into a ghostly blue dawn. If one ever formed in our galactic neighborhood, Earth would not survive. Luckily, none are near enough. But the fact that such power exists at all is humbling. Magnetars remind us that the universe isn't just vast, and it's alive with extremes. It holds places where time and energy blur, where matter bends into light, and where magnetism reaches beyond comprehension. Look up at the night sky. Every star you see is calm compared to a magnetar, and somewhere unseen, one of those invisible monsters is waiting, its heartbeat pulsing once every few seconds, sending out whispers of radiation across the galaxy. Each pulse travels for thousands of years, and tonight, one of them may be touching the skin of your hand as you watch this. That faint radio hum you'll never hear. It's the echo of a dead star still speaking. In the end, magnetars are a paradox of existence. They destroy, and yet they create. They twist reality, but reveal the hidden beauty of physics. They are the edge of everything, and a reflection of our own curiosity. Because to understand them is to accept a truth both terrifying and wonderful, that the universe has no limits, only thresholds waiting to be crossed. So the next time you see the night sky, remember, somewhere out there, a star's magnetic heart beats stronger than physics itself. And even in silence, the cosmos hums with their impossible truth. If this journey through the universe moved you, don't let it end here. Subscribe to Impossible Truth and join us as we continue exploring the questions that defy reason, yet define reality. Because the story of the cosmos is far from over. Stay curious, stay awake, and never stop chasing the impossible.